Today we are going to be learning about how to do Riemann sums written in summation notation.
Our function is 1/5 x minus 1 squared plus 2. And this is the graph of the function. And today we're doing a right Riemann sum with 8 subintervals.
In order to help you understand what I is, we have labeled each rectangle on the graph because I is equal to the number of rectangle that you are on, not the total number of rectangles. Okay, so now we're solving for delta x, and for this equation, it's going to be equal to 1/2.
So this is the formula for writing a Riemann sum in summation notation, and that's how you find delta x. So this n is the number of rectangles. I equals 1 means you're starting at 1, which will be different if you were starting at 0, 2, or whatever. This is your function with I incorporated into it, and this is just delta x, which is b minus a over n.
This would be our equation written in summation notation.
So I equals 1 because we're starting at 1 and we're doing a right Riemann sums. If we were doing left or midpoint, it would be something else. 8 because we have 8 rectangles. This is our function in relation to I, so that 1/2 I over there replaced the x, and this 1/2 is delta x. So 1/2 I is delta x multiplied by I, and whatever you get, in this case it's 1/2 I, that replaces x in your new equation. So now we're just writing out the Riemann sums for the first rectangle, which is basically just the function, and you replace I with the number of rectangle you're working on. So since we're doing 8 subintervals, we're just going to keep on going until we get to 8. So this whole inner part is the function, and that 1 that replaced the I is the number of rectangle. So now we're doing rectangle 2, we're just adding that on. So you're just going to keep adding them as you go. And once again, 2 is the number of rectangle we're on, and that just replaced the letter I.
After each rectangle has been written, your function should look something like this.
So this is what it should look like when you're done. It's meant to be done by hand, but for the sake of time, we're just going to show you the answer because it's a lot of math and fractions.
Make sure you check your work!
Here we're checking our work on a calculator, but we're going to show you more in depth how to do that later on in the video.
Now we are going to show you how to do summation notation with a calculator.
Our function is just the same one as before. This time we're doing 16 subintervals, which is why we're using a calculator, because that's way too much to do by hand. So to get the summation symbol, you press math 0, and then you would just plug in the numbers as you wrote them down on your paper. Here we're using like the actual fraction bars just so we can visualize it better as how we did it on our paper. and just so we ensure that there's no mistakes, but you don't have to do this part.
Here is another example of a Riemann sum with 18 subintervals. The function that we will be using is the square root of x plus 3, and since we will be going from 0 to 10, our delta x will be equal to 5/9.
So now we're just writing it in summation notation. R of 18 equals, and then the summation symbol, 18 on the top, and that's the number of subintervals. I equals 1, because once again we're starting at 1. And then you're going to do your function, and remember to replace x with delta x times I. So instead of x we have 5 over 9i, and then we copy the plus 3, and then multiply the whole thing by delta x. So again, this 18 comes from the number of subintervals. This is the function, just the 5 over 9i replaced x, and this 5 over 9 is delta x. Now you can plug this straight into the calculator just like how you see it. So once again, you press math 0 to get the summation symbol, and then you just plug it in like you see it. And here we're again using the actual fraction bars, which you don't have to do. It just helps me visualize it better and to ensure that I don't make a mistake. So here we're writing the limit statement, the limit as n approaches infinity, which is basically the same thing as when delta x approaches 0, because if you think about it, b and a are two fixed numbers, so, and if n equals infinity, b minus a over n, anything over infinity, is basically the same thing as 0. So then we're writing the summation notation, I equals 1, and n, which is just the number of subintervals. And then we are writing our function with I instead of x. And this whole thing equals the integral from 0 to 4, and it's 4 because that's where our graph ends. It's not 8. 8 is the number of rectangles. And then it is just f of x dx. So here's what the whole limit statement looks like.